When we go and measure the cosmological constant, which is responsible for the current expansion of our universe, what we actually measure is over 120 orders of magnitude smaller than what we actually predicted. That is a pretty big discrepancy.
This is called the cosmological constant problem, and it is one of cosmology's greatest problems. One of the solutions to this problem is to say that perhaps our universe is a lot larger than what we see in our telescopes, and in fact the cosmological constant is a random variable, and the average one is what we predicted, and we live in a place that has a very small cosmological constant.
But wait, that is clearly not enough to actually resolve the problem.
It doesn't explain why we are living in such a unique place with such a small cosmological constant and a small expansion rate, and not in one of the other places.
Well, the answer to that question that I came up with together with my collaborators is that while there were other places that were expanding as expected in the early universe, by now they are all destroyed. And soon, so will we.
Though I should note that by soon I mean in about 10 billion years, so you do have time to vote for my video.
In our new proposed model, the entire universe is filled with a gas that we can only really measure by its effects on the cosmological constant. The expansion of our universe is cooling down the gas until it condensates to a liquid. The liquid phase has a negative contribution to the cosmological constant.
The reason our universe is expanding is that it has a positive cosmological constant. A negative cosmological constant will lead to contraction and an eventual collapse. Therefore, the regions of space that had a larger rate of expansion had their gas turn to liquid earlier and therefore also collapsed much faster. And so, 13.8 billion years after this process begins, which is now, all that is left is our own slowly expanding universe, until one day we will also be gone. Now it may seem like the problem is solved and my PhD should be waiting in the mail, right? Well, first of all, this is only a part of my PhD. I did only have 3 minutes.
But more importantly, it turns out that if some regions are expanding extremely fast, then the transition from gas to liquid doesn't happen in them, and these regions survive to this day.
So we need something else to explain why these regions don't exist. And we already have quite a good idea of what that might be. But that, my friends, is a story for another video. Thank you for listening, and I hope you've enjoyed.